where all of our weather comes from. And we fly just
above,
near the top
of the troposphere. So we don't go above it, we on the top.
We can, but we don't. Some very high-flying craft, like the U-2,
right,
that would go into the
Now, do we fly at the top of the troposphere because it's...
You're above all the clouds. Why fly through clouds if you don't have to? It's less turbulent, and air is thinner, so there's less resistance to the movement of the plane.
Then why doesn't the plane fall out the sky, man?
It's going really fast. There's a buoyant force from the air that is there. By the way, but you make an important point. There's an altitude above which it would have to fly really, really, really fast to get enough air going below it to give it the lift.
Gotcha.
So the higher you go, the faster you have to travel to stay flying. So the SST, the Concorde SST, the first and only ever supersonic transport for commercial aviation, that was up at 45,000 feet, around there.
Right.
Currently, we fly in the 30,000, 35,000 feet.
Ladies and gentlemen, we've reached our cruising altitude of 37,000 feet, and quite frankly, I'm freaked out.
All right, where was I?
So we're in the troposphere, and now we're at the top of the troposphere.
Temperature drops to like 50 below zero.
Okay.
50 to 60 below zero. Then we go to the stratosphere.
Okay.
Something interesting happens in the stratosphere.
Go ahead.
That's where a molecule of oxygen has 3 atoms instead of the normal 2. The O3 molecule, turns out, sees ultraviolet light and it absorbs it, takes it out of action.
Gotcha.
But where does the energy go?
Oh, that's so cool, though.
It's very cool.
That's why we're not dead. Thanks, O3.
Yeah, not dying from skin cancer.
Exactly.
Right? So the UV molecule is completely gone. The persistent absorption of ultraviolet light in the stratosphere causes the temperature to rise because the particles are now getting an injection of energy that gets manifested as the kinetic energy of the particles themselves. And we measure the average kinetic energy as temperature. So, stratosphere, the temperature rises.
Whoa.
Yep.
That's wild.
Here's an interesting fact. Because the stratosphere is warmer than the troposphere, because the stratosphere is heated by the UV-absorbing O3 molecule,
right?
What happens to heated gas?
It expands.
It gets less dense and then rises.
It rises,
okay?
yeah.
What that means is the boundary between the troposphere and the stratosphere is completely stable. There is no urge for minus 60 degree air to rise.
It's almost like a ceiling that is created.
It is a thermodynamic ceiling above our troposphere. And that's why our weather never trickles. Yeah, okay. It's a lid.
That's so cool.
Containing basically all of our weather.
That's amazing. I love it.
That's why a volcano can pop through that.
Right.
It can pop through. But if it pops through and goes into the stratosphere, it's not coming out.
Right.
It's going to stay there.
And that's why it's circular.
That's why it's
all the way around.
Without falling out.
Without falling out.
Without falling out.
Dude, that is so crazy. I love it.
All right. So next, we get to the mesosphere.
All right.
I like me some mesosphere. You know why?
Why?
The air is way thinner now, but it's enough air to matter to interplanetary particles that the Earth plows through in its orbit.
Interesting.
Enough air to make some action. Okay? We intersect these particles very fast, 20, 30 miles per second.
Pretty fast.
So fast that the impact of those particles with that atmosphere, even as thin as it is, slows down the particles. Where'd the kinetic energy go?
Well, it's got to be somewhere.
Got to be somewhere. So it renders the atmosphere aglow.
Oh.
And we get meteor showers.
Nice.
So the mesosphere is meteor showers.
That's pretty cool.
Isn't that kind of cool?
Nice.
That's where all that happens.
That's where that happens.
And it doesn't happen in the troposphere.
Right.
Because
well, once it gets down there, it's like...
oh, by the way, it can happen down there if it's big enough.
Right.
Big enough, it'll try to burn up. But if there's still some left over, it'll keep coming down.
And if it's even bigger, you lose a barn somewhere.
Or you lose your dinosaurs. Yes, okay. That's the mesosphere.
Very nice.
Okay, now we get to, what's next? The thermosphere. Now the thermosphere is another layer that absorbs high energy light from the sun. It absorbs high energy UV,